Welcome to the Kirkwood School District Sound and Light 6th grade science. We're going to take a look today at our goal of looking at how the properties of a medium can affect the speed of the sound. Speed of sound depends on three factors. The first factor is elasticity, how elastic that object is, how dense that medium is, and the temperature of the medium. All three of those things affect how sound can travel through that medium. Take a moment to take a look at the table for speed of sound. You see it's got gases, liquids, and solids. It has speed. It also has some notations of different temperatures in degrees Celsius. So for example, if air is at 0 degrees Celsius, it travels slower, sound travels slower than through air at 20 degrees Celsius. So you see as temperature increases, the speed of the medium, or the speed of the sound through the medium also increases. Liquids and solids are very different states of matter than gases. So when we're thinking about liquids and solids, we see that the speed of sound travels faster in those different mediums. That's going to become important as we look ahead to these different pieces of information. Let's take a look at elasticity first. Elasticity is the ability of a material to bounce back after being disturbed. The more elastic a medium, the faster sound travels in it. Sounds can travel well in solids, which are usually more elastic than liquids or gases. The particles of a solid do not move very far, so they can bounce back and forth quickly as the compressions and rarefactions of a sound wave pass by. Most liquids are not very elastic. Sound does not travel as well in liquids as it does in solids. Gases are the worst. They're not very elastic at all. Sound travels very slowly in gases. So when we're thinking about elasticity, we can also include density. Density is how much matter or mass there is in a given amount of space. So if something is more dense, it has more stuff, basically, in a smaller amount of space. It's more compact. Okay? So if you imagine these two objects, you see they have very different masses, and they have the exact same volume. Keeping that in mind, since this one has more mass, it has more matter in the same amount of space, therefore making it more dense. Okay? When we're taking a look at the speed of sound, we can look at materials, the same state of matter, whether it's solid, liquid, or gas. Sound travels more slowly, slower in the denser mediums. The particles of a dense material do not move as quickly as those of less dense material. Sound travels more slowly in dense metals, such as lead or silver, than in something that is less dense, iron or steel. You can kind of imagine that because if it's more dense, they're more packed in there, and the particles can't move as easily. They don't move as easily if they don't have that elasticity and that ability to bounce and move, then it's hard for sound to travel. Temperature also affects the speed of sound. In a given medium, sound travels more slowly at a lower temperature than at higher temperatures, and we kind of already saw that. Now, why does that happen? At a low temperature, the particles of a medium move more slowly than at high temperatures. So it's all about the speed of the particles. So they're more difficult to move when their particles are cold. They're moving slower. So they are more difficult to move and return to their original positions more slowly. Okay? You can imagine that if you're really, really cold, you always want to kind of clump together, and it's not easy for you to move and change and do other things when particles are really, really cold. So we've learned about three properties that affect the speed of sound. The first one, elasticity. The second one, density. And the third one, temperature. We're going to wrap this up with a YouTube video reinforcing that information. I'll see you soon.
Since sound is a wave, it travels at a definite speed. But the speed of the wave depends on what it's traveling in, the medium. Imagine a race. 3 speakers. Emit a beep all at the same time. Beep, beep, beep. Time equals 0. Which beep is going to win the race? Beep. In air, the speed of sound is 340 meters per second, about 1 mile in 5 seconds. Beep. In water, the speed of sound is 1,500 meters per second, about 1 mile per second. Beep. In iron, the speed of sound is 5,000 meters per second, about 3 miles per second. On the other hand, a flash of light, a light wave, travels at 300 million meters per second, or 186,000 miles per second, much, much faster. Now, for most purposes of human sensation, the speed of light is infinite. You may already know the application of figuring out the distance to a lightning strike by measuring the time it takes for the sound to get to you. The light gets to your eyes almost instantly. But the sound, on the other hand, travels much slower, 340 meters per second. That's about 1 mile per 5 seconds. So if you count the amount of seconds between the light and the sound, you can accurately predict the distance to the lightning strike. Every 5 seconds you count, 1 mile of distance.